Alright guys, here we go. Here's your first video. Sorry. Alright, here's your first video for your summer assignment. We're going to start with talking about mean value theorem and Rolle's theorem. So we've got a differentiable function and we've got these points, so we're going to go ahead and plot them. So we've got the point 0, 1, so 0, 1, 2, 5, 4, 8, 6, 10, 8, 11, 10, 10, 12, 8, 14, 5, 16, 1, and we get a nice looking curve here that we can see is definitely differentiable. So we've been talking about lots of interpretations with the derivative, and a really important one, of course, is rate of change. We've been talking about two different types of rate of change. We spoke about average and instantaneous. So just to make sure that we're really clear and distinguish between everything, average rate of change is saying that on some interval a comma b, the average rate of change is, just like the slope formula, b minus a. For this one, we're talking about the slope of a secant line. Instantaneous rate of change is the one that we really started talking about and introducing in calculus this year, and this is saying that at a value x equals a, the instantaneous rate of change is defined by the derivative. So it's defined by f prime of a. Now we're talking about the slope of the tangent line. Tangent line, yay. Okay, so average rate of change of the function on this interval, we can say f of 2 minus f of 12 and 2 minus 12, or vice versa, however you want to do it. F of 2 was 5, 12 was 8, 2 minus 12, so we've got negative 3, negative 11, 10, so we've got positive 3 over 10 as our average rate of change. Then we've got to go over and talk about the instantaneous rate of change at x equals to 4 and determine if it's greater than the average or the instantaneous rate of change at x equals to 6. Well, if we look at the curve and think about x equals 4 versus x equals 6 and think about the tangent lines to each of those, we can see that the one at x equals 4 is steeper than the one at x equals 6. So the instantaneous rate of change at x equals 4, also known as f prime of 4, is greater than at x equals to 6 because the slope of the tangent line is greater at x equals to 4 than x equals to 6.